The math intervention resource I wanted to share is from the National Council of Teachers of Mathematics Illuminations website, and it is the game Pan Balance for Numbers. The goal of this game is to use this tool to strengthen understanding and computation of numerical expressions and equality. In understanding equality, one of the first things students must realize is that equality is a relationship, not an operation. This is the game screen, and so we have a balance here, and we are going to balance the red side with the blue side. So we are going to just put a number over here, and let's put 28, and then we're going to go to the blue side and try to balance that. And we have just finished a study in our class using base 10 blocks to make numbers. And so now I want to have my students actually use those numbers instead of the blocks to make the given number. And so let's say we have 2 base 10 blocks plus 8 ones. And now if you'll see, this equation came over here. And so whatever caused the balance to equal both sides, then they bring that equation over here. And so I went ahead and I set up some examples to show you. So 28 equals 20 plus 8, or 10 times 2 plus 2 times 4, and breaking that 20 here and that 8 here. Or if I knew 14 times 2 was 28, but what if I had a student that doesn't know that and they just chose to do 12 times 2 and say they knew the 12 times 2 as part of their basic facts, and then they just added 4. So as the teacher, I can come over here after a student has completed this work here, and let's say I assign them 7 ways to show me 28, and I can come over here and make sure that they have showed me 7 different ways to demonstrate the number 28. Then we're going to come over here and reset the balance and reset the table and start with new numbers. Depending on the subject matter we were covering at that time in class, I could use this program to check my students' number sense and ability to carry out different skills. And so with this one, 756 was the number I used, and this particular student could break it down to hundreds, tens, and ones using addition. And this one could break it down into hundreds and subtracting. This one could multiply and add this problem out, and I'll slide that over. And then this one, if we were working on exponents in the class, then this would also give them practice of using exponents or cubing squares or cubing numbers. Another aspect of this game that I thought would be very valuable is you can take a math problem on one side and find another math problem that equals or balances that original math problem out. And so I took the math problem 33 times 15, and I broke this 33 into a 30 and a 3, and this 15 into a 10 and a 5. And so you can come over here and see that I did 30 times 10, 30 times 5, and then for this 3 times 10 and 3 times 5. I did the same thing with 12 times 17, breaking it into 10 and 2 and 10 and 7. We could also use parentheses and show this 10 times and have it in parentheses, and the 2 times and have it in parentheses. And what this does is it allows me to go in and assess what strategies my students are using to find equivalent math problems. I can see how I then could follow this part of the game up with my students and ask open questions as to how they went about these steps to see if they could justify their process.